So we have one last type of factoring to talk about today, and that type of factoring is factoring special cases. And that's exactly what they are. They're just sort of unique cases that happen that we want to make sure we can factor. Okay, so special cases, for the most part, the one that you really have to be able to do is the situation where we are given two terms. Okay, so we're going to look at a couple things that sort of qualify as a special case, but there's only one that's truly, if you don't know it, you won't be able to get an answer. Okay, and this is if we have something that is two terms, but it also has to have a couple special features underneath there. Not only does it have to be two terms, those two terms have to have subtraction in between them. Okay, and each of those terms has to be a perfect square. Now, a perfect square means that we can think of a number times itself that will give us that answer. And that doesn't necessarily mean you know them all. I can show you how to do that in your calculator. Okay, so in your calculator, if you want to check and see if a number is a perfect square, we're going to take the square root of the number. And to do that in your calculator, you're going to press the second button, right, which is up here. So you'll press second. Okay, then you're going to press your x squared button. So you'll press second, then you'll press x squared, which is right here. Okay, right above the x squared, you'll see that square root button. So that's why we're getting the square root. And then you'll enter the number. So maybe if we want to check if 121 is a perfect square, we'll type in 121 and then equals. Okay, it gives us 11, so 121 is a perfect square. Okay, maybe we want to check and see if 360 is a perfect square. So we'll do second, x squared, 360. This gives us a big, long, messy decimal, which means it is not a perfect square. Okay, so to check the number, we're using our calculator. We're doing second x squared. For the exponent, it has to be an even exponent. So if it's like 25x squared, right, the exponent needs to be even. Okay, if we can decide that we are in a special case, then it's really easy to factor. So let's say we are given 25x squared minus 9. Okay, so first let's check our list. Is it two terms? 1, 2. Yes, it is two terms. Is it subtraction? We have a subtraction sign. Yes, it is subtraction. Okay, are they perfect squares? Well, again, we could check if we needed to. Okay, so we're going to check the square root of 25 is 5. Now, if it is a perfect square, we're going to make a little note of that. Okay, so 5 times 5 is what gave us 25. Now, let's check 9. Yep, that's 3. Now, if you know those without using your calculator, that's fine as well. Okay, and then we need an even exponent. So, yep, x squared has an even exponent. Okay, so once we know that it is a special case, we want to actually find out what number times itself gives us each of these. Well, the 5 we already did with our calculator. The 3 we already did with our calculator. For the exponent, we're going to take half of the exponent. So half of 2 gives us 1. Okay, and what this says is 5x times 5x gives us 25x squared, and 3 times 3 gives us 9. Once we have those numbers, we're just going straight into our factored format. It's two binomials, where the 5x is going first because it was first. The 3 is going second because it was second. And then one of these is getting an addition sign and one is getting a subtraction sign. It doesn't matter whether you put the addition or the subtraction first or second, right? Those can be flip-flopped. You just have to have one of each. Okay, after that, the rest of it is pretty straightforward no matter how big or small the numbers are. So maybe we have something like x squared minus 169. Okay, so this is two terms. It is subtraction. Let's check and see if 169 is a perfect square. Yep, that's 13. This has an even exponent, so we're good to do this as a special case. So we'll take half of the exponent, which is just 1, or just x. And we will then go into 2 binomials, where the x goes first in each of them. The 13 goes second. 1 gets addition, and 1 gets subtraction. And this is our answer. Now, even if this problem gets way bigger, so maybe we have something like 16x to the 8th, y to the 4th, minus 1. Right? It looks a lot bigger, but that doesn't mean it's any more difficult. We're still going to do the same idea. So this is 2 terms. It is subtraction. Okay, and the exponents are even, so let's check the numbers to see. Well, 4 times 4 will give us 16. 1 usually tricks my students, but 1 times 1 is 1. So 1 is a perfect square. So this will work, so let's keep going. Let's take half of each of those exponents. So half of 8 is 4. Half of 4 is 2. So I'm going to go into 2 binomials. Right, my 4x4, y2 is going first in each set. My 1 is going second. And just for sake of mixing it up, 1 addition and 1 subtraction, but again, it doesn't matter which is which. The only last thing I'm going to add to this is just to really make sure that you are keeping the order consistent. Okay, you cannot mix that order up, which means if we are asked to factor something like 25 minus y squared, okay, it's 2 terms, it's subtraction. 25 is a perfect square, it's 5. 5 times 5. Take half of our exponent. Right, this y is second, so it has to be what's second in our parentheses. The 5 is first, so that's first. 1 addition and 1 subtraction.